the following equations algebraically. What that means is we get x by itself and we figure out what it equals, right? So for this, the first step that I'm going to do is move my 40 over here, and that helps me to get my x by itself, so that gives me that x squared is equal to negative 40. Now I have something squared that is equal to something else, and I can take the square root of both sides. That gives me x is equal to plus or minus the square root of negative 40. Right? Now I have something under a radical, and it has to be simplified. Right? If anytime we have a negative, we can pull that out as I. Right? So let's start doing that. This is going to give me x is equal to plus or minus I times the square root of 40. Right? I'm going to start looking for perfect squares. I see a 4 in here, and I know that 40 is equal to 4 times 10. 10 does not, it's factorable into 2 times 5, but it does not contain any more perfect squares. So the only thing I can pull out of this is that 4. So I'm going to take the square root of 4 and pull that out. So x is equal to plus or minus 2 times I times the square root of 10. Okay. There's no other simplification that we can do, so that is our answer. Okay. So my next question, same instructions. I'm going to pull my 36 over to this side, so I can start getting x by itself. That leaves me with negative 4x squared is equal to positive 36. Right? Then I can divide both sides by 4, or negative 4, because I want to get that x squared by itself. Right? This is going to give me x squared is equal to 36 over negative 4. That's going to give me a negative 9. Right? Now I have something squared equal to something else. I can take the square root of both sides. This is going to give me x is equal to plus or minus the square root of negative 9. Right? Now we've got two things going on. We can pull out the I, because we've got a negative under there. So that is going to give me x is equal to plus or minus I times the square root of 9. Square root of 9 is 3, so we can pull that out as well. That gives me x is equal to plus or minus 3I. No other simplification we can do, so this is our answer. Our next set of instructions tell us to write the quadratic in transformational or vertex form, state all of the transformations, and draw a graph of the function. Be sure to graph the vertex and intercepts. Right? So let's get going. First thing I want to do is isolate my first two terms. That is going to give me negative x squared plus 6x, leaving some space, minus 5. Right? I need to have the x squared by itself. I have a negative in front of it. That means I have to pull a negative 1 out. So that's going to be x squared minus 6x, still leaving space. Right? It's time to start finding that magic number. So I'm going to come off to the side here, and my middle term is negative 6. So I'm going to be looking at negative 6 over 2 and squaring it. That's going to be negative 3 squared, and that is going to be 9. So in here, I am going to add 9. Now here, I am going to subtract 9. Now I got to be careful, because this 9 is multiplied by a negative 1. So my 9 on the outside also has to be multiplied by a negative 1. Right? Here, I wrote this deliberately so that it would factor as x minus 3 squared. Right? And then just remember, we get our negative sign based on this, and we get our n term based on this. This 3 is the square root of 9. This negative corresponds to the one that we did in the middle. Keep continuing to simplify. I have minus 5. This is a minus 9 times the minus 1. That's going to give me positives. So I have negative 5 plus 9. And that is going to give me a positive 4. This is my vertex form. So here I have f of x is equal to negative x minus 3 squared plus 4. So my transformations, I have several. Let's go through them one at a time. First one is this negative on the outside, right? That negative is telling me that we are going to reflect, oops, the x-axis. Next thing I have is this minus 3, and this is on the inside because the square root is on the outside of it, so everything in here is part of the inside. So that means we are affecting x, and it means that we are going to have a horizontal shift, right? We have negative 3, or we're going, what we think would be to the left 3, but the inside lies. So we are going right 3. My last transformation, I have this plus 4. This is on the outside because it is not inside of the square term. So this means we are going to go up 4. Right? So here, remember, because we are in vertex form, we are going to be, our vertex is going to be these two values here. Remember, it's h and k. So our vertex is going to be the point three, 4. Right? It's also asking for solutions. That means that we are going to have to set this equation equal to 0 and solve. We could also use the quadratic formula. We could also factor, but we've already got this in vertex form, so let's go ahead and do it that way. All right? So I'm going to set my function equal to 0. So I have negative x minus 3 squared plus 4 equals 0. I'm going to move my 4 over here. That's going to give me negative x minus 3 squared is equal to negative 4. I can divide both sides by negative 1. It's going to make those positive. Now I have something squared equal to something else, so I can take the square root. That's going to give me x minus 3 is equal to plus or minus square root of 4. Right, we're going to continue that over here. I can pull that 3 over to the other side, so that gives me x is equal to 3 plus or minus the square root of 4, which is 2. Right? So x is equal to 3 plus 2, which is 5, and x is equal to 3 minus 2, which is 1. So my two solutions these are going to be 1 and 5. That means that I have two x-intercepts, right? So now I have some things that I can graph. I have my vertex, which is at 3, 4. I have my x-intercepts, which are at 1 and 5. Right? I know, based on these transformations, that this is reflecting the x-axis, which means it's facing down. Right? So we've got that already. We are over to the right 3. 1, 2. Yep, because normally we'd be at 0, 0. Now we're 1, 2, 3 over and 4 up. Everything's looking good. Now normally a quadratic is going to have a point over each side. We don't have any vertical stretching or horizontal stretching. So that is as expected. Go down like that. All right, our next problem wants us to find the discriminant and describe the solutions for 7x squared minus 8x plus 1 equals 0. So let's get started on that. The discriminant is going to be b squared minus 4ac, right? Here, a is whatever is in front of our x squared, that's going to be 7. B is whatever is in front of the x, that is negative 8. Our c is our constant, which is going to be 1. So my b squared minus 4ac is going to be negative 8 squared minus 4 times 7 times 1. Negative 8 squared is 64. 4 times 7 is 28. Right? This is going to give us 36. So my discriminant is 36. Now if you remember, this is positive and a perfect square. Right? And if you go back in your notes, you'll remember that this means that we have two real rational roots. So here we're going to find the discriminant. First thing we need to know is what are a, b, and c values. A is whatever is in front of the x squared, that's 4. B is whatever is in front of the x, that is 8. C is our constant term, and that is going to be 6. All right, so our discriminant is going to be b squared minus 4ac. That is going to be 8 squared minus 4 times 4 times 6. This is going to be 64 minus 96. That is negative 32. Right? So anytime we have a negative discriminant, that means that we are going to have two imaginary zeros. Right? Now, the way we need to find those, we either complete the square and solve, or we are going to have to use the quadratic formula. If we have imaginary zeros, this is not going to factor. Right? So let's go ahead and use our quadratic formula. X is equal to negative b. That is going to be negative 8 plus or minus the square root of b squared minus 4ac. Right? That is going to be 64 minus 4 times 4 times 6 all over 2 times a, which was 4. Start working this through. Negative 8 plus or minus the square root of negative 32 over 8. Right. So a couple of things we can do. We've got a negative on the inside. Let's go ahead and pull that out first. Negative 8 plus or minus I times the square root of 32. If it helps just to always do that as one step on its own, go right ahead. If you can skip this and do the next step too, more power to you. All right, so I want to find perfect squares that are part of 32. All right, I can pull out 4. That's still going to leave me an 8. So let's think of bigger numbers that are perfect squares that might be part of this. And sure enough, 32 is equal to 2 times 16. 16 is a perfect square, 2 is not. I can pull the 16 out by taking the square root. So this is going to give me negative 8 plus or minus 4 times I times the square root of 2 over 8. Right? Now, I have a couple of things that I can divide here, but I cannot divide everything by 8. I only have a 4 in front of this square root of 2. All right? So if you need this extra step, please take it. My GCF here is going to be 4 times negative 2 plus or minus I times the square root of 2. And this is over 8. Right? I can divide these. This leaves me with a 2 in the denominator. So this is going to give me negative 2 plus or minus I times the square root of 2 over 2. I cannot factor this anymore because I don't have anything divisible by 2 in front of my second term. So this is my answer. And sure enough, there's our two imaginary zeros, exactly what our discriminant predicted.